What's up, y'all? This is Hussein Nasser from IGeometry, and today we'll continue with our new series, ArcGIS add-ins for C Sharp. Alright, so last time, let's see what we have done. By the way, I fixed this magic mouse. Now I can right-click. It was an option, apparently. So everything is disabled in Apple, guys. Everything is disabled by default. They want to make everything as simplistic as possible. So everything is disabled. You go and enable stuff that you usually do. And it's essential stuff, like a right click. How about that? Alright, so last time we did the information model, right? For our phonetic, that's a terrible name. Okay, so we're gonna, let's stick to it apparently. So we're gonna continue with this this company who asked us for to fix their dying business, basically. So they're suffering from very bad reception and very bad customer reviews. People are moving from their service to other companies, so we try to help. They reach out to us, and they're new to GIS in general, so we want to implement GIS technology to help them improve their telecommunication system, basically. So we want so this is what we started with. Okay, this is a very simple. They don't know what they want. They do know what they want, and they asked us. And remember, was a huge story that we read last time, and we cracked it open into. So we squeezed an information model from all this story, right? So, and we came up with. Okay, go. Yeah, we came up with this baby. This is small information model or data model, whatever. A data model is a very specific niche things. Like information model includes other stuff too, right? So information model includes applications too. So here we have a feature class called tower. So towers are very essential things in any telecommunication company. So you need to have towers, and each tower, this is a feature class of type point. So as we said, tower point, and each tower has a band which is 4G, 3G, etc. Each tower can have details like a coast, coverage, height, base area, all these things. And each tower has, this is one-to-one relationship, and each tower can have 0 to many tower logs. So what is a tower log? Basically, these are customers or users who connected to this particular tower by ID. Right, and we record the IME, I forget what it stands for, International Mobile, forget what it stands for, something. So it stands for like an identifier for some sort. So apparently each smartphone or each phone has this unique identifier, and of course a timestamp of that particular connection. This is in order to find that particular, but by the way, we did not store the location, right? But we don't need, because in the tower we have the location. So if I have a record here, for example, on August 17, 2007, if we have a record of someone in this with this IME to this tower, we can establish somewhat their location within a buffer of this tower, right? We spoke about this. Anyway, we're gonna this is not written in stones. This can change. It's fine. We're gonna change it as we see fit. All right. Are we recording? Always want to see if I'm recording. I'm recording. Good. So we close that. Today we're gonna dive into. I think we're gonna dive into programming. But before we do that, I need to speak about some boring history. All right. So history of ArcObjects. and how and COM and .NET, and you know, how we are, why are we programming in .NET as opposed to COM, and all these very important things that you need to know. And these things, because we're getting into advanced, right? This, from this point, if you're watching this series, this is an advanced kind of series. So if you want like kind of beginners series, this is not an advanced, this is even an intermediate. So I'm going to talk about concepts here. I'm going to talk about uh, frameworks, concepts, you know, technology, not only coding. So you need to have some sort of a basic understanding, and this is what we want to provide in IGeometry. All right. So this is episode 3. This is what we're gonna talk about. I hope this is clear. I think this font is big enough. So the first thing is we're gonna talk about common.NET frameworks. Then we're gonna talk about the interaction between .NET and COM. Then we're gonna create some features in our geodatabase that we created last time. That, by the way, this is what we did last time. We created a geodatabase for our company. All right, last thing, we write an add-in in C#. Yeah, we're gonna write it in C#. And this gonna span into multiple episodes, I believe, because this is like the first thing. We cannot write this tool. This will definitely get broken into pieces, and we're gonna do that. All right. First thing first. First thing first, I'm a realist. Drop that, then it was no sellers. Talk about COM and .NET. So what is COM? So why are we bringing this now again? So why are we talking about COM? Some people will say, hey, I want to code now. I want to start coding with ArcObjects. So why are you bringing these concepts? Well, these are very important, you know, because back in 1993, I think, if I'm not mistaken, yeah, 1993, COM was invented, right, by Microsoft. So why was it invented? The COM stands for Component Object Model. The reason it was invented, this was the step into the object-oriented realm, and nobody ever stepped into that. People tried, but this was the first attempt into object-oriented. So now with COM, now you can create object of classes. So you have you can have a class called dog, you can have a class called cat, you can have a class called God, I forgot all animals. Dog and cat. Jesus. Okay. I don't have any animals? Come on. All right. All right. Can't believe this. All right. So whatever. So dog, cat, llama. Come on, sheep. Yeah, sheep is a element. Yeah. So these are panda. Yeah, thank you. Panda. So all these are animals, right? So what do they share? But I just said it. Okay, all these are animals. So all of these share some sort of they inherit this concept of animal, right? Or mammals. You can say mammals to be specific, right? Don't grill me on the spelling, okay? I don't care. All right. So animal. So all of these are mammals, but these are instances of animals, right? Not an instance. These are classes of animals. So a dog is an animal, cat is an animal, sheep, panda, all these are animals, okay? So before COM, before object oriented, you cannot do this. You cannot have, for example, an animal function or method called make sound, and then dog will have make sound of, it will basically, this implementation these four implements animal, right? So all of these guys make sounds. I don't know if a panda, what sound a panda makes, but whatever. It makes a sound, right? We were yesterday in a zoo, in a San Diego zoo, so we saw a panda. So it was sleeping anyway. It didn't make any sound. So yeah. So make sound. Animals in general. If you'll talk in object oriented, this is called an abstract class, or sometimes it's called even an interface. You can do it in an interface, or uh, so it has some sort of shared properties and methods, and these guys implement this class, right? It implements this class, and thus every single class of these, like dog class or cat class or sheep, can have its own implementation, different implementation, but yet every single object can then be casted back as an animal, right? So if we're talking code here, we can say something like that, right? Animal A equal new dog. You can say animal B equal new cat. Animal C equal new panda. And because you love panda, you can add another panda. Animal D equal new panda. It's another panda. And for fun, you can have a name for your animal. That's fine. It's a pet. You can have a name for it. So you can set names on this. Okay. Now, I don't get an error when I set a new instance of a dog class into the abstract class A, because these guys inherit from animal. So I can basically cast these easily. This was not possible before. I don't think if there is a concept of a class before. Everything was like a sequential coding, and you cannot arrange, you cannot share code, you cannot execute remote code, you cannot execute this code from different places, so I can do all this now, and I can make an array of animal. How do I make an array in C#? Forgot. I think it's animal or something like that. Cool, new array maybe. So animal, something like that. Animals dot add. You can do that now, and it will be definitely fine. See, I'm adding all these into an array, and I can loop through this array, and I don't care anymore what is inside this now. So I'm treating now, I am working with an array of animals, and all animals make sound, and all of them have names. So this is the way this is a very important concept, by the way, to program for an interface, not an implementation. This is like the first thing I ever learned. This is a very, very, very important concept right there. So in object-oriented, if you want to get into this realm, you have to know this. Never, or let's say, avoid programming for an implementation. So if you have a class called dog cat, don't say dog D equal new dog. Don't say that. Try as much as possible to cast this into a generic interface so you can reuse it later, because believe me, you will. And I know some of you who had already worked with this and say, hey Hussein, sometimes there are functions that are only specific for dogs, like dogs can, what does that, they guard, for example, or they, I don't know, they attack, not, they don't attack, they basically scare thieves, right? So like this is like some of their concrete method. So sometimes you have to do that because now in this case you are programming to a concrete implementation. No, your application does not code against generic concepts. You're coding against specific concept for dogs that is not shared between all animals. So that's a very thing. So okay, so that's a lot to talk about for object oriented. We can maybe visit it later, but this is the concept. So this is COM, right? COM allowed you to do this. Now you can actually, a dog can inherit into animal, and it also can inherit other things too, right? Like mammals. So let's have a class called mammal. Okay, a mammal is basically it's an animal, but it doesn't lay eggs. Basically, that's the only difference. So a dog inherits from a mammal, and it also inherits from animals. So they actually both inherit from this. So there are things specific to mammals, and there are things specific to animals in general, and that allows you to do this. If you inherit from this, you can actually do that. Like mammal m equal a. I can do that. Why? Because a dog inherits from an animal. A dog also inherits from mammal. So I can literally say m equal a because an animal is also a mammal. In this case, a dog. The underlining concrete class is a dog, and a dog can inherit from it. But give me an example of an animal that is not a mammal. Got a bad with examples. Yeah, I have to come up with an example. What's an example that was an animal, but it's not. It lays eggs instead. So yeah, we can do birds. Ostrich. Okay, an ostrich is an animal. Technically, it's a bird, but give me a break. Okay, this is an idea, right? But it's not a mammal, right? So I can do, for example, ostrich O equal new ostrich. I can say animal A1 equal O. That's okay. But if I say mammal M equal O, this will break, right? Because these guys does not implement each other. Although because an ostrich, the actual you have to look at the actual instance. Where is this going? Deep down. So O is an ostrich. Ostrich implements animal, okay. Ostrich does not implement mammal, so bad. So this will break. Alright. That was a long COM introduction. So that was COM, right? COM was good. That was a good technology. People now can create object and they can compile it into DLLs, and then you can reuse this object like we do in ArcObjects. So you can write all these implementation into a DLL called zoo, for example, right? And then reference this DLL into your project and work with this implementations, right? Like make sheep sounds, or make panda sounds, or add all these animals into a loop of array and then loop through them and make different kind of noises. Fun stuff, So this is, by the way, called if you do a loop now for each animal, new animal in animals, if you do that and you said new animal dot make sound, this is right there. This is called polymorphism. So that's the beauty of polymorphism. Polymorphism is basically coming from executing multiple different kind of logic, having the same exact code, line of code, you know. So the first loop is a dog, so it will be like a dog now, barking sound, right? Second will be a cat, a panda, and then another panda. So two panda sounds, all right? So that's like whatever panda sounds like. All right, so com, that's com. Com was great. It's working, and everybody is thankful for com for this huge, evolvement of the object-oriented realm, right? So, but com was only a branch, really. It was very focused, and it's not a. It's only one branch, really, of just making object of things, not So it has its limitation, So Microsoft need to build something bigger than that, bigger than com, right? And it needs to evolve. If it didn't do that, it will not evolve. Com is just a bunch of objects, right? Classes and concepts, really. But now Microsoft needed to get into the cloud, and even before cloud services, for that matter, right? And com was bad at that. You cannot call an animal class from your web, right? From your web, you cannot do that. So wasn't there. There's no services concept. There was no interoperability. You cannot publish these things and consume them very easily. There's no standard, really, and there was very limited programming languages that fits com, and it was very fixed in that term. Although it was a concept, but it was kind of it was a very fixed concept. So that's a very big difference. We cannot, by the way, compare .NET to com. They cannot be compared. This like are oranges and apples. No, it's not actually oranges, apples. Much bigger than that. It's like comparing a fridge to something inside the fridge. What's it? So like apples inside this fridge, right? So a content, this .NET is actually a bigger concept, So that's really a very bad example, by the way. But you get the concept, right? So you get the idea. So .NET is the bigger thing, right? So it supports, you can write in multiple programming languages. So let's go down here. So .NET. So this is a framework. What is a framework? Framework is something very big. It includes multiple programming languages. You can compile them into a single language, and it also have nice object-oriented concept right there. So it inherited com, but it didn't actually comply with com standards, because it had to build its own standards, right? So it had to come up with completely different things. And we are still recording. Yeah, no problem, because these videos can go up to 5 GB. I have to be careful with my limit here. All right, so just to not run off memory here. So yeah, 1080 guys. Yeah, so multiple programming languages into the common intermediate language, I think, CIL. So they invented the concept of CIL, common intermediate language. What is this, basically? So they made up a language that but we don't understand it, we don't know it. It's not there. I didn't see it really. But whatever languages like C#, VB, .NET, I think J#, F#, all these crappy names, all compile into CIL. What? All compile into CIL, common intermediate language, and they have their own common runtime as well. I forgot the name. I think common intermediate runtime, something like that. Right. So there is a runtime that is common between all of them. So no matter what programming language you use in this supported programming languages, they all compile into CIL and then into the common runtime for .NET framework. And that's a great improvement. To do that, they have to invent their own technology to do that, right? And by the way, Java had the same concept. Java, Java has a GIR, I think. Again, something like intermediate runtime, something like that. GIR, forget the name. I'm not that very good in Java really, but I don't know who repped the other. But probably Microsoft repped the Java. But don't take it from me. I don't know who invented this concept of shared runtime and shared languages, right? So if you notice that when you want to install Java application, you have to install this Java runtime. What do they call it? Java virtual runtime, something like that. It's a virtual box so that runs on top of your operating system, and then your code will be executed for that runtime, basically. JRE. Oh yeah, yeah, that's it. JRE, Java Runtime Environment, I think. All right, so that's a big huge, and there's also the object-oriented stuff. So still the same comish stuff. Still it has the breath of COM, but it's not actually COM. So it has the breath of COM, but it's not actually COM. That's very important. And the last thing is the supports WCF, which is Windows Communication Foundation. Now I can execute shit across different platforms. Cool, man. We cannot do that with COM. I mean, you cannot build that on COM. Let me correct that. You cannot build such technology on COM alone, right? But COM is great. People still using it. So now we know COM, we know .NET. We go back to our concept. Interaction between .NET and COM. Dun, dun, dun. So let's go pull back into the current topic, which is GIS. So GIS, Esri Technology has built this literally the best GIS engine on the planet, hands down. ArcObjects. There is no GIS engine that tops that up to this date, and that's, I'm telling you with very great confidence, because basically I work there and I've seen the people say this, basically. So ArcObjects, there is no GIS engine as big as ArcObjects. It's very fine grained. What is fine grained? If you hear this term, so fine, when you chop something very finely, means that you basically make them smaller and smaller, right? And that's what ArcObject is. It's a very strong component object model. Yes, ArcObject is built around COM. It's all about COM, nothing else. That was the idea behind it. They built it around COM and still maintained COM, and it's written in C++, right? The whole ArcObject is written in C++. Whole ArcMap is written in C++, for that matter. All right, so we have that, and we have COM, and if you see any object model for ArcObject, you will see how very finely they are chopped, these classes. There is a class for layer, there is a class for feature layer, there is a class for geo feature layer, there is a CAD feature layer. I'm not sure that this is a thing, but it's very finely chopped, as opposed to other models like I don't know if you're familiar with this, but like Miner, Telvin Schneider uh, model, for example, it's a coarse grained. It's opposite of that. So they don't like to chop things off. They like to chop things very in a big portion. So you will not find something called layer in them or feature layer. You find only layer or map, and that's it. All functions, more functions on this map. Esri model is, and I'm not saying there's bad. One is bad and one is good. Really, it depends on you. Really, I like the fine-grained approach because you can call that particular method, to do your stuff, to do your class. But it's sometimes it's harder to find things in fine-grained. Like, let's say you want to create, you're gonna find it now. If we have the time to start writing code today, I don't know if we will, but if we do, you'll find that it's actually it's a bit challenging to find a particular function and to do something. Like if we want to add a symbol of a picture on the map, that's a symbol, right? So there's an interface called iSymbol, and there's like thousands. Okay, that's too much. There's like tens of interfaces, classes that implement symbols, like pick a marker symbol and simple marker symbol, and there is a line symbol, and there is a picture marker symbol. So all these have concrete methods that does stuff, and these methods are basically arranged in these classes, so each method is basically handled there. So add picture stuff, you create a class of this, right? There's no something like that, and other if this was a course grained, it would be like this. That's it. It's simple. I don't care. Simple.add picture. So here you'll find add picture, for example, right? Here you'll find, for example, from point to point, right? Because it's a line. Here you'll find a huge list of stuff here. Why? Because it's coarse, right? It's big portion, but all your methods is in one class. All right. So actually, we started to talk about more things then. All right. Again, where are we? ArcObject. Yeah. All right. So ArcObject is built on COM. Problem is that people started to adopt .NET, right? I'm not even using this magic mouse. All right. So where? Okay. No. What is this? Interaction. Yeah, we're here. So people started to use .NET, right? And .NET and COM are different technologies. But people need to communicate. They have COM stuff. We have COM stuff. We have ArcObjects. But we're building applications on top of .NET. Why? Because this is the new world, right? We want to build services eventually. We want to program with different languages. I don't want to use C++. I mean, I don't want to program different million lines of code to write like a point on the map. Literally, you have to write a lot of code to do that. So I want to use .NET that simplifies things. I want to use these common libraries that are built in this cryptography. By the way, the .NET thing that we didn't mention with .NET is that since we have now common languages, there are common libraries that are built on top of the CIL here. So there are libraries that are built ready to build and use for you. And you couldn't do that with COM before, right? Now you have cryptography library, paint library, drawing libraries, all kind of libraries in .NET, and that's why people love it. You know, forms, you can draw forms, you can draw all these things, you know. So it's really simple to use .NET. Everybody's using .NET because it's really simple, and it saves a lot of time to do that. All right. Okay, so ArcObject uses COM, .NET uses apparently .NET, so we're going to use C#. How do I call ArcObjects? Previously, there was no way to do that. Then Microsoft said, okay guys, since you want it, I'm gonna let you talk to your COM stuff, alright? But you cannot call .NET to COM directly because apparently they use different standards, right? You cannot just reference a COM into .NET and just call it. Actually, now you can, because they have this, they invented something called, probably you know that, COM interop. Yeah. So how does that work? COM interop, basically these are, let's say I have a class in COM called symbol, right? Or marker symbol or iSymbol, right? And I want to use that in my .NET. So who's responsible for COM, basically? The one responsible for COM is for ArcObject in COM are Esri, right? So Esri is responsible to build something called the interop for COM, so .NET can use it. So there will be something exactly like the iSymbol version, but instead for .NET. It doesn't necessarily call .NET symbol, but it's exactly have the same signature. So if there's a method called add to map, there will be a method here called add to map, and it will be basically mapped between these things. So if you are here into .NET, now you can literally call iSymbol s you can do this in .NET, and that's because why? Let me do this. Yeah, and now that you can do this because there is an COM interop that communicates these two guys together. And now, the moment you create a reference on .NET, .NET creates something called, and this is very important, it's called RCW, Runtime Callable Wrapper. It's literally a wrapper. It just wraps your COM object with another interop object, right? And they call it RCW. That's it. So every time you create an object on .NET that references COM, a corresponding RCW is created, right? Okay, guys, today I'm gonna not code anything. Let's just continue talking about this. This is a very important topic, by the way. So people who already program with ArcObject probably know this, or probably don't. So they are used to now this is another era. This is literally another topic, really. This is very important, so let's just spend some time explaining this. I see. So previously I thought this will be a very short, but it's not actually. This is very important. So this is COM, and this is .NET. Let's open the, yeah. So this is .NET, this is COM. I'm gonna create, so if you create an object here, no. If you want to call the object rectangle, for example, this is a square, by the way, square, red square, you have to have a red square, but for .NET, right? An interop for that, right? So that's a similar red square, but it's like, I don't know, thicker, for example, for some reason, right? so that these two guys communicate, right? So this calls this, and that is called the RCW. Oh my god, this is very big. That's what she said. Yeah, this, yeah. So this is my RCW. So the is it RCW? Yeah, this is RCW. Runtime Callable Wrapper. So it wraps this and it eventually calls COM. Problems. What are the problems here, guys? Okay, this lives in another territory, right? So this is, by the way, we did not mention this. This is also called, there's another name for this called, this is called managed code. Because you are managing it. You are running, this is where you run your stuff. See how the, the cursor gets bigger. Woo! That's the magic mouse, baby. Alright, managed code. This is called unmanaged code. Why? Because literally it's unmanaged. It's like getting into forest here. So once you call this, you are on your own, baby. If you call a method here, this method tries to go into the realm of the forest, of the unknown world, of the evil calm. It's not evil, it's just scary calm. People are getting scary when you get here. So it's unmanaged. You cannot go here and do stuff here. You don't have full visibility on your COM object. You're not writing COM object. You're writing .NET code. You're not writing COM code. That's very important. Whatever you're writing here, whatever we'll be writing in this series, whatever we have written in the extending ArcObjects series, it's all .NET code. And it talks to COM, but it's only a wrapper. It just wraps this object, but it doesn't know everything. It's responsible, the wrapper responsible for clearing this. Like if I used it and I said, once you basically want to clear this object, okay, you just leave it and the garbage collector will take care of it, right? So after a time, .NET waits for a time until all RCWs go and call a method called, I think it's called dispose, not dispose, something else. But it just kills this COM object because this COM object have to be killed, you know? The problem now here is sometimes some people use, and it was instructed by Esri sometimes way before, and that's really bad, by the way. You should not do it. Now, some objects, two objects of COM can actually reference the same. Two objects of .NET can reference the same RCW on COM, and that's where you can get into trouble if you start manipulating things, you know. So if you, for example, used some of you are familiar with this Marshall concept of releasing and COM object, right? So some people will use Marshall.release COM object, and then they supply this RCW, right? So they call this, and what does, if you call it on this object, this will be killed, but this will remain. And that's where things got really messy. You know, you don't want to do that. You don't want to call release COM object at all. Leave everything to the garbage collector, and it will take care of things. It will clean things properly. Because if you know what you're doing, if you're some developers know what they're doing, they know when to call this. But I've seen some people, like beginners in ArcObject, they just call this release COM object after each, basically every method. I mean, I'm saying, if you read my code before, extended. I never use this once in my code because I don't need it. Garbage collector take care of things. It literally take care, but it takes time. It doesn't just, when you exit your subroutine, it doesn't go and clean things up for you. It just waits for all, basically all objects that are calling the RCW to say that I'm not using this anymore, so it goes and clean this up. But it doesn't. So forcing a garbage collector to collect things is bad, and forcing an object to be cleared is also bad, unless you know what you're doing. What? For example, I'm going to give you another example. So let's say this is a file, geodatabase, all right? So you're opening a feature class. This method opens a feature class, and in the next line, you want to clear that object, right? Obviously, if you set it to nothing, it will not clear that lock. The lock will be still persist on that file because the RCW is still connected. Setting this object to nothing or to null does not clear it, right? Because, are we still recording? Yes, we are. Yeah, because if we set this object to null, the RCW still lives, and it's the job of the it's the job of the garbage collector to clean the RCWs, right? The caller wrappers. So even if you set this workspace to nothing, this object might still be living and the lock might still be on it. So if you're in the next statement, you want to use that to edit for example, something in the file, you might not be able to because this lock still persists. Now, this is just one example that you need to use the release object, but I just try to avoid it because if you release this object, you better own it. You better know what you're doing because you're gonna get this nasty error. Let's Google it. Some people already found that. So, object has been separated from its RC, something nasty like that. There you go. Object that has been separated from its underlying RCW cannot be used. So someone has meshed up with this object, manually tried to clean it up. But you cannot use it anymore because someone has, outside the garbage collector territory, someone has bypassed the garbage collector and tries to kill that object, right? That's bad, guys. Let me save this under Picasso to .NET. Yeah. All right, guys. So that's a very brief. It's not actually brief. Yeah. It's just a very good introduction about this, and I'm telling you this because, guys, yeah, it's very important. Just leave things alone. Don't release stuff. Just whatever I write to you here, you can depend on it on your coding. You don't have to release stuff manually unless you know what you're doing. Unless you're an expert, that's another story. But in my coding experience with ArcObjects for 10 years, I don't use release. I don't release stuff. I did it once, and it was for a script that runs in batches of million records, I think, 1.5 million. So I had to do a release after the first 500,000 record in order to release everything, and then I continued. But I knew what I'm doing. I don't release stuff when I'm opening a file database, for example, right? So you have to be careful with this, right, guys? So, all right. I think that will be. Let's stop here, and we're gonna continue with episode 4 here. Okay. I'm sorry, guys. There's no coding in this episode too, but believe me, we get to coding. Gonna get a lot of coding, and soon enough too. Right. All right, guys. This is Hussein Nasser from IGeometry. See you on the next one. Goodbye.